Hi folks, we're going to take a look at this problem here, which is an example of determining the type of shape that's created by a set of points on a Cartesian plane. Okay, so since these are points on a Cartesian plane, this is an analytic geometry problem. Okay, so the question is determine the type of quadrilateral formed by the points A, B, C, and D as given. Okay, now again, we're going to assume that when they're given in alphabetical order like that, they follow in that order. So you have point A, then point B, then point C, then point D. Okay, that they go in order. Now whether it's in clockwise order or counterclockwise order doesn't matter. Okay, but in the end, when we think about the different types of quadrilaterals, it has to do with comparing the sides. So for example, if there's one pair of parallel sides, then you've got a trapezoid. Okay, if you've got two pairs of parallel sides, then you've got a parallelogram. Okay, if you have two pairs of parallel sides and those sides happen to also be at right angles to each other, then you have a rectangle. Okay, and of course, if all four sides are equal, that rectangle is a square. Okay, but we see that the initial thing we have to look for is are there any sides that are parallel to each other? Okay, and the way to show that is to compare the slopes. Okay, and in fact, beyond just being able to compare whether two lines are parallel, the slopes are also going to help us determine if there's any perpendicular lines. Okay, so our goal here is to find the slopes between all 4 points, okay, and see what kind of conclusion we can make. Okay, so first I'll start with the slope of the points of the line that joins A to B. Okay, so again, our formula for slope is y2 minus y1, so 3 minus negative 5 over x2 minus x1, negative 2 minus 8. Okay, so here we've got 3 minus negative 5 is 8. Negative 2 minus 8 is negative 10. So we reduce this fraction and we end up with negative 4 over 5. Okay, so let's move on now to the next line. Let's go to BC. So the slope of BC, okay, let's use our slope formula. So y2 minus y1, so 8 minus 3 over 2 minus negative 2. Okay, so 8 minus 3 is 5, and 2 minus negative 2 is 2 plus 2 is 4. Okay, so now these are adjacent sides, meaning they're sides that are joined together, AB and BC, and there is a relationship between them. Okay, we notice that if you look at these two slopes, they're negative reciprocals of each other. Because if you take 5 over 4 and you take the negative reciprocal, you get negative 4 over 5. So that means that these two sides are perpendicular to each other. So, we might end up having something like a rectangle here, but we have to check the other sides. Okay, so let's now find the slope of CD. Okay, so here y2 minus y1, so 4 minus 8 over x2 minus x1, 7 minus 2. Okay, and so here we have negative 4 over 5. Okay, so we see that these opposite sides are parallel. So we've got two sides that are parallel and a third side that's perpendicular to both of these other sides. So this point here, this is really looking like a rectangle. Okay, so let's find the last one. So now let's find AD. So let's do y2 minus y1, so 4 minus negative 5 over 7 minus 8. Okay, and so here we have 4 minus negative 5 is 9 over 7 minus 8 is negative 1, and that just gives us negative 9. Okay, and so that's where my initial conjecture falls apart, because I see that while these two opposite sides are parallel, those two opposite sides are not parallel. Okay, so if I have only one pair of parallel sides, it means that I must have a trapezoid. Now, it just so happens that it's a trapezoid that has one right angle, but it's still a trapezoid because there's only one pair of sides that are parallel. Okay, so only one pair of parallel sides. So it is a trapezoid. Sorry about that. So let's just do a recap. This case here, I had a quadrilateral for corners. And in order to determine what type of shape it was, I had to find the slopes of the lines joining all the points. And in this case here, because there was only one pair of parallel sides, it turned out to be a trapezoid. Okay, that's it for this one.